Hi guys, it's Dr. Shaw. Today's going to be the first day that we're going to try to learn something a little bit new. It is still connected to probability, and it's our last real skill that we haven't yet learned in class. So I'm also trying to learn this new software while we go, so have a little bit of patience with me, and hopefully it'll be fun. Ooh. All right, so I'm going to put tiny me up here. Okay, so what we're learning today is called contingency tables. So a contingency table is a way to compare the relationship between two separate variables. So in this table, the one right here, you can see that we have two categorical variables. We have medicine taken and we have cold length. So a lot of businesses like to use this type of table because it allows them to see how two separate things interact. So for instance, you might be interested in someone's age and what type of sneaker they prefer, because then those are the people you would advertise to versus anyone else. So we're going to look at this table and we're going to use the probability rules we've already learned about, and we're going to try to make some sense of it. So let's see how we do. All right, there we go. The very first question just asks us, what are the two questions people had to answer in order to make this table? So like I said, all contingency tables have to have at least two variables. And our variables here are, medicine taken and cold length. So they most likely asked people, how long was your cold? And they could either answer 1 to 3 days or 4 to 7 days. And then they would ask them, did you take medicine? And they can answer yes or no. The second question is, how many people had a cold? So basically, how many people did they talk to? And you can always tell that right here in the total area. So the first probability question is asking, what's the probability that someone who had a cold took medicine? So we're first hopefully going to highlight this column, because this is the group of people who did take medicine. We know how many people had a cold. That was all 200 of them. So that's going to be our denominator. And now we're looking at those who took medicine. The total number of people who took medicine was 102. So the probability that someone who had a cold took medicine is 102 out of 200. But that's not a very easy number to compare. So anytime we come up with a probability from a contingency table, you should turn it into a percent. So I do 102 divided by 200, I get 0.51. That means 51%. So about half the people were likely to take medicine. The next question asks, what's the probability that someone who had a cold for 4 to 7 days took medicine? So this time, let's see if I can figure out the erase. Oh yeah, I managed to erase that. All right, I'm back. I figured out how to do some erasing. So we want to look at the probability that someone who had a cold for 4 to 7 days took medicine. So I'm going to highlight this row because we're only looking at these people, and we want to know out of them how likely was someone to take medicine. So that means I'm really just interested in these people. To express it as a probability, 16 will be my numerator because they took medicine. Out of everyone who had a cold for 4 to 7 days, that will be this number down here, 95. And again, I'm just going to express that as a percent, which gives me 16.8%. Okay, so for the next question, we're looking at what's the probability that someone took medicine, that's this column, or they had a cold for 4 to 7 days. That's this column right here. Now, just like our probability rules before, the or part means that we're going to add two separate probabilities. So the probability that someone took medicine, we get from this number, 102 out of our 200. Or means add, so I put my little plus sign. And now I need those who had a cold for 4 to 7 days. That would be these people. However, I can't write down 95 because if you notice right here, these 16 people I've already counted. I counted them in the group that took medicine. If I count them again in this group for 4 to 7 days, that's like saying 16 extra people answered this question. So I can only take the group in the blue that I hadn't yet counted, which is those 79 that didn't take medicine. So I put 79 also over our total of 200. My denominators are the same, so I can simply add the numerators and put it on top of the denominator. And then I'll turn that into a percent, and I get 90.5%. And my last question asked me to find the probability that someone did not take medicine. So let's highlight the column of people who didn't take medicine. Or they had a cold for 1 to 3 days. And let's highlight that row. So for the first part of our question, the probability that someone did not take medicine, that would be 98 people out of the 200, or still means add. And now I'm looking for those who had a cold for 1 to 3 days that I haven't counted yet. So I'm not going to recount these 19 people because I already included them. I'm only going to count these 86. My denominators are the same, so when I add it up, I get 184 over 200, and I go ahead and simplify that down to 92%. Now, all right, so now I'm going to want you guys to give it a try. There we go. Before you continue the video. So in order to do that, I want you to start by finding the totals. You need those right here. And then see what you can do with the next 4 questions. So go ahead and pause the video and come back. All right, hopefully you paused the video and you tried all these questions. So let's take a look at how I got these answers. First, you should make sure you have a total of 118. And you need to make sure it totals up vertically, that's in the column, and horizontally, that's in the row. These two have to match. If they don't, you've done something wrong with your addition. All right, so for the very first question, I tried to color code it to help us out a little bit. If we're looking for a student who is an 11th grader, there are 65 11th graders. The or still means we add, and then I wanted anyone else who had a cell phone that I hadn't counted yet. So I went and looked at the 12th grade. 50 of them had cell phones. When you add them together, you end up with 115 over 118, and that gives you a percentage of 97.5%. On the second one, there is a really easy mistake we can all make. So the first part with the green, we're looking at who has a cell phone. That's almost everybody in our table. When we look at has a cell phone, we see it's 109. That's right here. And then we want to pick anyone else who is a 12th grader that we haven't counted yet. It's really easy to accidentally put 53 because we know there's 53 12th graders, but we already counted 50 of them when we asked who had a cell phone. So we're only looking for this last 3. So 109 plus 3 gives you 112, and when you divide it by our total, you have 95%. And then our last 2, change it back to what we were doing before. We only wanted to know the probability that a student who doesn't have a cell phone is from 11th grade. So we look at just the 11th grade column. Sorry, we look at just those who don't have cell phones. That would be 9 of them. 6 of them are from the 11th grade, so 6 out of 9 turns into 66%. And something similar for 11th grade. We see that 11th grade that has a cell phone. We see that 59 out of 65 of them had a cell phone. All right, what I would like you to try now is, on the back of this. So in April of 1912, you might have heard of this ship called the Titanic. So it sank on its maiden voyage, and more than 1,500 of its estimated 2,224 passengers died. But one of the cool things that they have figured out is that where you were on the ship had a lot to do with whether or not you survived. So each class, which is what we list up here at the top, had its own level on the ship. The higher the class, so first class was the best class, the closer you were to the deck. If you're closer to the deck, you're more likely to be able to get out in time before the ship sank. So I want you to answer these 7 questions. At the very bottom, I want you to think about what an insurance company would think of this sort of information. So based on what they have learned from past accidents, how might that affect what they do in the future? All right, guys. I hope this video was informative, and I'll see how well I can get it up into Google Classroom. See you next time.